Derive the flood hydrograph of a catchment in response to the given storms. Phi index for the catchment is 0.25 centimeters per hour. Base flow was 10 meter cube per second at the beginning and increased by 2 meter cube per second after every 12 hours till the end of the direct runoff hydrograph. The ordinates of the unit hydrograph are given. So these are the ordinates of the unit hydrograph. This is the rainfall data. So in the first 6 hours the rainfall was 3.5. The second it was 10 minus 3.5, and in the third interval of 6 hours it was 14.5 minus 10. The loss was 0.25 centimeters per hour. So in 6 hours it will be 0.25 multiplied by 6, and we will obtain the effective rainfall or excess rainfall. It is equal to 3.5 minus the loss. So the values of the effective rainfall have been obtained. Now let's say from 12 am to 6 am, for the first 6 hours the rainfall was 2, and it was 5, and then it was 3. Excess rainfall values. Now the rainfall lasted for 18 hours. Okay, and these are the ordinates of unit hydrograph. Let me show it in graphical form. Yes. So this is the unit hydrograph of this catchment, 6-hour unit hydrograph. Now the direct runoff hydrograph will be calculated from ordinates of unit hydrograph. So the first direct runoff hydrograph resulted from 2 centimeters of excessive rainfall. So we'll multiply the ordinates of unit hydrograph by 2. Now the next rainfall occurred after 6 hours of interval. Yes, direct runoff hydrograph resulting from 5 hours, 5 centimeters of effective rainfall, and in this column it is direct runoff hydrograph resulting from 3 centimeters of effective rainfall. Now we'll lag this by 6 hours. So 12 am, 3 am, 6 am. Here the direct runoff hydrograph resulting from 5 centimeters of effective rainfall will start. So 5 multiplied by the ordinates of unit hydrograph. Okay, and the next direct runoff hydrograph will be lagged by another 6 hours. So the total lag will be of 12 hours. Yes, so it will start at 12 p.m. So 3 multiplied by the ordinates of unit hydrograph. Okay. Now the composite direct runoff hydrograph will be the sum of these 3 columns. So sum of DRH resulting from 2 centimeters, 5 centimeters and 3 centimeters of rainfall. Now, the base flow was 10 meter cube per second initially, so it will change after every 12 hours. So 1, 2, 3, 12 and 4. Now it will change. It will increase by 2 meter cube per second. So 12. Then 14. Then 16. 18. Then 20. Okay, this is the end of the direct runoff hydrograph. Okay. Now the flood hydrograph will be the total of the ordinates of composite direct runoff hydrograph and base flow. So sum of DRH plus base flow will give us the final flood hydrograph. Now let me show this in graphical form. So this is the direct runoff hydrograph resulting from 2 centimeters of effective rainfall. Then this shows the DRH from 5 centimeters, then 3 centimeters of effective rainfall. This is the composite direct runoff hydrograph. Let us add the legends. Okay, so here it is. So this is how we obtain the composite direct runoff hydrograph, and we can also show the flood hydrograph. This is the flood hydrograph.